Hello, welcome again to this videos on basics of aeronautical engineering. Today we are going to look at the various aircraft materials. This is the first portion of the of this part. What are the aircraft materials? We'll have a look at it, and plus we'll also have a look at the various mechanical properties that these materials should possess. Okay, so it is important that we understand all the meanings of the terminologies and the properties of the of that is required for these materials to possess uh, when we are using it for the aircraft. Okay, so let's get started. What materials are used in the aircraft construction? Yes, the main groups of materials are used in aircraft constructions are steel, of course, and then the aluminum alloys, titanium alloys, fiber reinforced composites is being used. Titanium alloys possess a high specific properties and have a good fatigue strength, tensile strength ratio with high fatigue limit, and some retain considerable strength at temperatures up above or upper to from 400 to 500 degrees Celsius. Now that is why these are being very much preferred. And but let us understand what is this terminology: fatigue, the strength, the tensile ratio, etc. All that way. Okay, let's get started. The mechanical properties of any material is given here. We will have this video in two parts. The first part we will talk about a few of the properties, and then we'll move on to the other properties in the second video. First one is the elasticity. Elasticity is that property that enables a material to return to its original shape and size when the forces which causes the change of the shape is removed. When I have a material, I pull that and within the elastic limit, if I leave it, will go back to the original position. Now, this property is extremely valuable because it would be highly undesirable to have a permanent part permanently distorted after applying a load and it was removed. So most of our table, chairs, etc., all that we are applying load. But all these things are within that elastic property, and each metal has a point known as the elastic limit beyond which it cannot be loaded without causing a permanent distortion. In aircraft construction, members and parts are so designed that the maximum load to which they are subjected will not stress the member beyond their elastic limit. The desirable property um, is, uh, is generally the steel. The plasticity is defined as the property of the material by virtue of which a permanent deformation without fracture. It should get yielded, but then it should not fail. There should not be a tearing out or separation of the material takes place wherever it is subjected to an action of external deforming forces or load. Thus, after the elastic limit, if the load is increased, the material is no longer capable of regaining its original shape and size, and the permanent set of deformation occurs. Metals like lead, copper, zinc possess good plasticity. By means of this property, the metals can be shaped into some kind of components and machine parts without fracture. Ductility. Ductility is the property of a metal which permits it to be permanently drawn, bent, or twisted into various shapes without breaking. Now, this property is essentially for metals made for making wires, tubing, etc. Ductile metals are greatly preferred for aircraft use because of their ease in forming and resistance to failure under shock loads. For this reason, aluminum alloys are used for the cowlings, fuselage, and the wing seam, and formed or extruded parts such as ribs, spars, and bulkheads. Chrome molybdenum steel is also easily formed into the desired shape. Ductility is very similar to the malleability. Similar in the sense that ductility is more for making wires and malleability is more for making sheets. Brittleness. Brittleness is a property of a metal which allows little bending or deformation without shattering. Shattering here means breaking. A brittle metal is apt to break or crack without change in shape. Because structural metals are often subject to shock loads, brittleness is not a very desirable property. Cast iron, cast aluminum, or very hard steel are examples of brittle materials. Beyond some load, they will break abruptly without warning. Hardness. Hardness refers to the ability of the material to resist abrasion, penetration, cutting action, or the permanent distortion. If I say a material is hard, then it means it is going to resist the wear. It is going to any denting, etc. It is going to resist the denting. Now, hardness may be increased by cold working in the metal, and in the case of steel and certain aluminum alloys, by heat treatment. Now, there are two ways by which you can try to work on the material. One is on without heating in the normal ambient temperature, and which is called as cold working. And the other one is when you heat it and then work on it using some hammer or forces. So structural parts are often formed from metals in their soft state and are then heat treated to harden them so that the finished shape will be retained. Hardness and strength are closely associated with the properties of metals. Toughness. Toughness is the property of the material by virtue of which it can absorb maximum energy. So if there's a material and I'm giving it a force, okay, so it tries to withstand the shock loads, the load, etc. Tends to withstand. Thus, it is the capacity of the material to withstand shock loads. A material which possesses toughness will withstand tearing or shearing and may be stretched or otherwise deformed without breaking. Toughness is a desirable property in aircraft metals. Stiffness. Stiffness is the property of material by virtue of which it resists deformation. Modulus of elasticity is the measure of stiffness of a metal. The end of stiffness is the starting of elasticity. Of the material steels have high stiffness are used in spring controlled measuring instruments, and steels are this springs, etc., they have the stiffness, and it is represented by K. So in this video, I think we will uh, stop here on the various property. We will have it on the next video, which will follow immediately. Thank you very much. We will stop here.